Sketch the graph by performing transformation. State the domain, the range, and the asymptote for each function. In this case, we see that f of x equals log base 2 of x minus 4 is a transformation of the function y equals log base 2 of x. We know from the basic that y equals log base 2 of x looks like the generic log equation graph. When x equals 1, log base 2 of 1 is 0, and so on. We can plot a few points to graph this function y equals log base 2 of x. What does log base 2 of x minus 4 is doing to this graph? It will simply shift this graph to the right 4 units. And so, instead of the point x equals 1, y equals 0, we will shift it to the right 4 unit, 1, 2, 3, 4, 5. And so 1, 0 is now 5, 0. For log base 2 of x, there is a vertical asymptote at x equals 0. But again, we will shift it to the right 4 units, and so the vertical asymptote now has to be x equals 4. The graph would go through the point 5, 0. And it is the logarithmic graph. This is the graph of y equals log base 2 of x minus 4. And again, as usual, we should plot a few points. The argument of log need to be positive, so in this case, to find the domain of this function, we would need to have x minus 4 strictly greater than 0 or x greater than 4. And so the domain of this function is a set of all real numbers that is strictly greater than 4. In interval notation, this is open parenthesis 4, infinity, because we need to take every number on the right hand side of 4, but not including 4. We see from the graph that the range of the function is a set of all real numbers. It goes all the way from negative to positive. In this case, the range is from negative infinity to infinity, or simply the set of all real numbers. And we already mentioned that there is a vertical asymptote here, and that is x equals 4. There is no horizontal asymptote.